QP. Welcome to Wizard Wars IO. Going to show you a code overview. So let's go into my repository cloned from GitHub. Seep into Wizard Wars. All right. So top level, we have is a server that runs the game, manages the WebSocket connections, also a static folder for serving the website, and then inside of the lib folder is all of our source code for the game. So I'll just open this up in Sublime and take you on a tour. So run.sh is how you start the server, and this is just really simple, just starts a Flask server. And if we look at run.py, this is the server that gets everything up and running. You shouldn't have to really do anything here, but just if you want to know like where the WebSocket management looping happens in here, and then in socketclient.py loops over, loops and sends a loop message to the game server run.py, which will send a loop message down the game. So this is sort of a meta stuff for managing avatars connecting to the server, and it's like on join game message. But you really shouldn't have to do anything here if you're developing the game. Yeah, so show you. So this does reference a client, and see that's a new client. So what is a client? So I'll just open up client.py. So client inherits from our roguelike client. You can see it comes from lib roguelikeengine.client and has some default levels, which will be randomly generated, select new level function, and target wizards. So target wizards controls AIs. If there are fewer than 4 players in this case, the game will spawn AI wizards to run around the map. But if there are more than 4 players, then it won't spawn any new ones unless the population dips under. And the default levels here, Town, Cavern, Arena, Temple, Labyrinth, and Bash. That's coming from the roguelike engine from our levels.py here, which will have levels in them. Okay, so diving into the roguelike engine. So cd the lib rl engine ls in here. So yeah, there's a client. Look at that first. It's a roguelike client, which basically serves the interface between the server and run.py and the rest of the game engine. Let's see default levels just has Temple. We override that in our top level client. And configure, we call by the entity class. And actually, we should go ahead and just look at entity, since that's the foundation for the whole game. So entity inherits from Python object. You can initialize it with a params. Defaults to active, and it has some properties. Pick up, attackable, pushable, momentum, components, and then also call setup default components. So everything in the game can have default components that it'll install. And so this function just goes through and looks at the default components and will install that onto the entity. By default, entities have no components, so you have to add in components. So like monsters will have, or avatars will have components on them that will give them behaviors like health and being able to take damage from things, that kind of thing. So yeah, this is our base object. And you can send messages to entities by calling .msg with a name and a value, so key value. And this will just go through and send that message to all of its subcomponents recursively, so everything can handle as it needs to. And when it needs to receive a message, handle message gets called, and then you can, in your subcomponent, check. So like if name equals loop, then clear and active. Yeah, then there's some helper things here as well, so like vector towards, orthogonal towards, just some helper movement stuff for entities, find the closest object, just some different utility functions in here. Yeah, okay, so back in our client, this inherits from entity, just use the component feature, but doesn't need all the movement stuff. And configured as called by the entity. So here we set an item.styleMap with the self-to-item style map. And this is in a function, so you can override it or swap this out for something else if you want. This uses style.itemMap. Just look at that, style.py. And this is our styling system. And this will map item names to codes, and then map those codes to appearances. So like fire potion is 150, and lightning wand is 160, etc. And we have some special names for effects here, poison, fire, acid. And then the style, got some comments showing like, here's for displaying characters with different kinds of armor here. Corpses, code 123. Here's all the monsters. So like a Minotaur, for example, uses symbol 547, color black, background color long green. And that symbol is the ASCII code. So we're using our own internal code and then mapping that over to an ASCII code or a character and then set of colors. So using our own internal system just to make it easier to track internally what's going on. So yeah, if you want to play with how things look, or if you add like a new kind of wand, come in here. Probably run out of room in the ordering pretty soon, so we'll just add in go up by 1,000 or something, and for wands or weapons, whatever, and just keep going. Excuse me. Okay, so back in the client, default components. Do we have, Riley, do you know if we have default components in this client? I don't think we do. I don't think it has any default components. Okay, it doesn't. Cool. Yeah, so it's called load level rotation, checks the default levels, and that will load in. You saw that we overrode that, and we'll add that to the level rotation. Yeah, there's some functions for like creating a new avatar, which run.py will call, create a new player, and check if there's something there from the same socket ID, that's the PID there, then remove that. So this should never happen, just as a fail-safe if somehow player got disconnected, connected. Then we'll create a new component, and here we're going to create an avatar class. Params are going to have a name, WebSocket PID, race of human, 50 health, and then some more params for attack and defense. So base power, base defense. And then we've got lightning as 0. That's really not necessary here, but if you don't include a key here, then it'll default to 0. So you can, if you want to try out avatars that had natural lightning resistance, for example, you could change that there. Yeah, make game comes, and this will get the game up and running. I don't think you'll need to do too much here if you're developing on here. This is shouldn't need to change much, but this kind of goes through and starts up the level, sets up the components, starts the game, gets a world map in the item manager, makes default items from the item manager, and then checks the level data to spawn some items there and any extra monsters. So don't really need to worry too much about what's going on here. This is sort of getting everything set up. So diving into game, game gets configured with a game ID. Right now we just have one game always running. Players, bots, and items, a leaderboard, is finish flag, which the run.py uses to determine if it's over or not. And if it's over, then it starts a new game. And you can see here we've got some, using the default components I showed you in the entity class. So it's got a default render, default turn processor, a default item manager, and a win condition component coming from the level object. Now, the default param for most objects in the game is just a MD dictionary. Don't really need it, but like item manager, we'll use the item manager config coming from the level object. So different levels will have different item configs, and different levels could also have different win condition configs, and also with the level name. So these all get installed as components on the game. And then you can see render, term processor, item manager. We just use our base classes. These are left as functions just in case in the future someone needs to swap out and use their own custom render or custom item manager or something. Well, you can do that here. You can even change the term processor. Just override this function, use your own class there, and everything else will stay the same. Yeah, and some leaderboard functions. Refreshing the leaderboard, displaying the first place points, creating a player. Don't think we actually need this anymore, Riley. Create players, since we have that coming from the game or from the client. Yeah. Get rid of that. Get rid of that too. Yeah, and then some functions for adding players, add bots, add items. Get player info. So this is what gets sent back to the client. So we call get avatar from some player ID. That's their WebSocket PID, and if they don't exist, return an error. If they do exist, we get the knowledge component. So this is how you access a specific component. You do it by the class name as a string, and the knowledge component is what that avatar knows about. So avatar have different properties, different components. The components end up storing everything in a single knowledge component, which is what they know about and what's going to get sent down to the client. So we will get their messages from no.msgs, and we'll just go ahead and check if the game's finished. Then we append a message saying who the winning wizard was. Change the status to finish. We have some text. This is what shows up at the bottom of the screen in the win condition column. And then the info dictionary here. So map, knowledge, map view, messages, inventory, their inventory. EQ indexes is equipment index, so that's which indexes different items are in. What events they know about, that's used by the client for animations. HP is the health. LB for leaderboard, movement, moves, and status. So if you end up adding like a really distinct kind of thing, I think that like events should kind of cover most of what you change in the game, but there's something really major. Maybe it's for a different game type, like a meta mode, like if it was capture the flag or something. You might add some other kind of data here to get sent down every tick. And yeah, if the player's dead, then they're no longer active, and we update their status to killed and a killed by text. And get player view, helper function for getting the map view from that player. Same thing for inventory, get player messages. Clear dead will get called every turn, and look at the world map, and then go through and remove any dead avatars, bots, or items. Avatars in this case refers to the player avatars. And yeah, we'll just go through and remove all that. Yeah, Riley, I think that's pretty much it for the game, huh? We have place items, place monster, which spawns items in the game, but I don't think there's a lot else going on here. I guess we should talk about the loop, actually. Like, that's probably the most... Yeah, I almost skipped over that. Yeah, term process is really where it gets interesting. Yeah, okay, so the game loop, yeah, we get the avatars, items, world map, term processor render, and this is going to go through every frame and message the term processor to process the intents for this map, for these avatars with these items here. And the term processor might yield events here, and might also yield new items. We'll add that to the component list and add that to our item list as well. So we've sort of got we'll always track everything that gets added will be a component, but we keep our own lists and the avatar list, bot list, and item list, just to do easier bookkeeping for like checking all the monsters or checking through items. We'll also check and see if anything spawned. Right now this is just zombies, but this could easily change. Like if you had a portal that spawns monsters, one of the items in the to-do is to like spawn a spirit that cracks out of the potion, something like that. We'd use spawn here. And this will just spawn the monster. Then we check for new items, add those, and we tell the render, hey, update your rendering with this new world map and the objects that are there, and update the views for all the players, and then we will release all the messages to the avatar, refresh the leaderboard, and check for finishing, and then lastly, clear dead, which will remove dead items. Okay, so now for the meat of this whole thing, which is the term processor. So, term processor. So this is where the core game logic happens every turn. Everything else before this was just the infrastructure or backbones. And if you're skipping forward in the timestamp, yeah, this is the meat of the game logic where everything happens. So, we've got Zap processor, movement, melee, ballistic, explosion, avatar manager, and spawn. So just a minute ago I showed you how the term processor gets messaged with the process intents message, and this is going to look at what the players and the bots are doing with their intent, and then update the world state for them, as well as any items that might be on the map, like a boulder moving as well. Okay, so first we aggregate the intents. Well, first we default reset events to empty. Now, right now, these kind of events are basically very explicit in the term processor. Maybe this should be abstracted out, but right now we are very taking an opinionated stance, like this is the stuff our game cares about, is these kinds of things. So very explicitly saying what kind of processors we use and what kind of events. Maybe there's some refactoring to do here, but I'm pretty happy right now. If we need to add more event types, we can. But it should be fairly straightforward to add them. You can see we're also just getting some references to the processors from self.components. Okay, so we'll aggregate the events, and we'll call adjust intent if they're dead. And this is just removing them if they're dead, right? Yeah. Python list comprehension. Yeah, so clear them out if they're dead. And what do we use moved for? Are we using that? Oh, okay, so avatar.moved is an offset for the client. So as the game runs turn by turn, one turn every second right now. So if you moved west, for example, then we would have to send down an offset with the X value change here to show you that to move the map over and keep your character position in the right spot. All right, so run turn, processor, trigger message. So this is a function we have for messaging the processor and then updating our events list here with processor.events. And Riley, just a quick aside here, I think we might be able to maybe take these event names out and then refactor this line that just checks, and if the key doesn't exist, then add it. Update does that anyways? Oh, okay, cool. We'll have to come back and test that out. Yeah, so on our turn, Zap processor, start process, movement processor, process moves. So at first glance, you might think, oh, I can just kind of treat these all the same, but we, I know with Zap processor, we do something special, right, Riley? Right, so you can get hit with a zap leaving a space or coming onto a space. That's why we have the start process and process for Zap processor. So we'll go through each processor in the turn and then call run turn on it, which will send that message and then do the updating. Yeah, Zap processor handles zaps from wands. I don't know. I don't think we need to go. Do we need to go into detail of how all this stuff works, or think just showing them the term processor would be fine? Yeah, yeah. Avatar manager. Okay. Well, yeah. So I'll just go through just a quick overview. So, um, zap processor. This is for wands being zapped. I think turrets can do zaps too. And basically that can either send a projectile out or might spawn something from the wand. Movement is people moving around. Melee will, based on their movement previously, they might hit each other, run into each other. Then we end the zap processing, so if you're moving into a space, you'll get hit with that. Ballistics are all projectiles, so potions being thrown, boulders, anything being thrown. And then explosion processor. So those are actually kind of related, the ballistic and explosion. So just looking at the fire potion real quick. When the fire potion lands, it has an event get saved on it with explode with some parameters, and this will actually get read by the explosion processor here, where it looks for at the items and just checks for anything with the explode key, and then it will create an explosion from that. So items and avatars will mark themselves with events, and then these different processors will pick up from that. Yeah, so avatar manager. So this is like the input for the avatar, as well as checking for them getting hit. So this is going to go through all the avatars, and let's see. So let's go through and check their intent. If they have an event hurt, which means they took damage this turn, then they'll we'll mark that as the events. So this will get added as an event for the avatar manager, and then this will eventually, excuse me, come back out and be read by the render. Is that right, Riley? The render reads the avatar manager? Okay. Cool. Cool. So the render reads the event, and then we'll change their codes. They flash red. We check for special events being melted, burned, shattered. These are different ways that different effects that can apply that can affect items, and they'll show up there. We don't have poison in there because I think poison just doesn't affect items like that. Yeah, check for dead characters. That's what all this is. That and AI, then we just remove them from the world map. Otherwise, we're going to create a corpse, and we'll call world map.replace item to replace the player with a corpse. And then we'll scatter the items, whatever they had. We'll just go through and randomly throw it around them. And then we have some checks for special event types. So the chaos event, this goes through inventory, will make you fumble non-equipped items. You have a chance to fumble. And if you're applying, then you're trying to use an item in inventory, so we just call a inventory.use item. We log whatever that use message is coming from that item. Switch, I think we just can switch with turrets right now. I don't think anything else uses it, but if you use the S key, you can switch. Drop lets you drop an item. So this is where you can drop, like if you drop plus the up arrow, you'll drop an item to the north of you. Digging, pickaxe uses that, and then some potions can be drank. I guess that's it for the avatar manager. Is there anything else we should go over? Maybe the render? Render would be good? Okay, so yeah, okay, so the term processor aggregates the events, and that's from this line here, right? This events.update. cool. So we're going through all the processors and we're sending in the message like process moves, process melees, and there might be an event there, and then we're going to save that event here. Okay, and then how does render read those events then? Is that what happens? Yeah. Okay, scene events. Cool. Hmm. Okay, so our render checks these different kinds of events, and we're getting these from the term processor, and it's going to compare these with the avatar's field of view. So for each avatar we're going through here, and this is all field of view stuff, and we're using libtcod, thanks libtcod team, for the computing the field of view. So you might observe a zap, a smack, a death, a throw, an item being dropped, an explosion, collision, someone being hurt, melted, fumbling, burned, or shattered. Yeah, so we'll go through all that, and for each event, then we're going to check the coordinates in each list of affected spaces, and if that coordinate is in there, then we save that based on the offset from the avatar, and yeah, say that in scene events. You can see down here on update knowledge, we will message the avatar with scene events, and this ties back into that knowledge, using knowledge as the one single data source that gets sent back down to the client in game.py. So here's where we can see knowledge.events comes from. Yeah, so that's a pretty good overview of the system, I think. Do we want to talk about anything specifically, like maybe AI or potions or something? Oh yeah, yeah, event witnessing and knowledge. Yeah. Okay, so this is sort of how the system ties in the events together. But as far as how individual avatars know about events, we're going to show you inside the avatar.py a little bit about them. So the avatar has a component called nerves, and nerves you can see. Well, Riley, we use nerves and witness, right? Don't we use now? Do we use witness in avatar? Where do we use that? Yeah, okay, knowledge has witness. Gotcha. Okay, so knowledge has witness. So nerves handles the effects, and then knowledge and witness handles the output, right? Okay, cool. So since I was already looking at nerves, I'll just talk about this quickly and then jump over to knowledge. So nerves, this is where all these events can happen for an avatar. So for example, the zapped updater will process an event, and all these come from an action updater which cares about a certain topic, in this case zapped. So hey, you got zapped, so you got hit for this much damage, and then delayed message, you are hit by, you are zapped by lightning wand from so-and-so and lose 30 HP or whatever it is. It's like processes game logic events. And then in the knowledge, this is actually what the player knows about. Deep log components has the witness and the zap witness. So this is observing things that are happening from the render. So to clarify that again, the action updates and nerves are like game events. Like the logical event happening, and then the witness is what you know about that, what you see something happened. So right now, looks like we have this returned out because that was kind of spamming the log, so just return none, but we could show here like, hey, so-and-so zaps a bolt of lightning or something. So, for example, burns. Someone burns to a crisp, turns to ashes consumed by fire. So this is just you observing this happen, not the actual fire damage happening. That's happening in the nerves and the avatar and health. Yeah, and the witness knows about these kinds of things: zap, smack, drop, death, melt, throw, explosion, fumbling, burning, and shattering. Yeah, anything else we want to cover? Or do I need to talk more about that? What should we do next? Okay. Yeah, like more updater information. Yeah, okay. So just to go into the distinction a little more between the nerves and the witnessing, we'll look at this equip updater, for example. So the toggle equip message gets sent, then this is the avatar toggling their equipment, so like equipping or de-equipping. This is something I believe we don't have a witness for because this isn't something that you need to know about. We do, however, have the render handle this another way by showing a different character code for what armor the player is wearing. But we don't need to send a message saying, hey, you see so-and-so, pull out this sword or whatever. So we don't. Yeah, so witnesses are more about processing events you see happen locally. That's going to be displayed on the front end on the client somehow, and the nerves is more about internally what's happening to you. So there's some overlap, but there's more nerves than the witnessing. So for example, drown updater, if you go into water, if you get the topic, standing on water, then you're going to take damage. And if you have a way of floating somehow, then if there's no damage, you would float peacefully on the water surface. Good luck with that. Yeah, so there's some stuff in the avatar you can read that'll sort of show you like how the main characters are working. We have adjust intent. This is the ASDF controls: apply, spell or switch, dropping, firing. This one gets used most often. And we also have AIs in the game that are avatars that have an AI component. So this install AI gets called. And this actually gets called from the item maker. Kind of jumping around a lot, but there's a lot of moving parts to this thing. So yeah, I have an item maker. We have a monster factory, which knows about these kinds of monsters right now. And so this gets the message to the make message. Hey, make an orc. Calling for the level requirements. Go in and check its specs, which is this here, and then make that monster. So in that case, it would create an avatar. We'll give it a render code based on the AI's render code. So for simplicity, we decided that the AIs wouldn't, the monsters wouldn't be changing their render code. So only the sort of wizard AIs would, but the orcs and trolls and everything, they're not going to be wearing equipment or changing the render code, just so that they stay distinct and easy to manage. That is one limitation Riley and I have talked about our rendering system. Is right now it's all on a code base instead of like dynamically drawing, a background and armor and a character or something. We kind of right, yeah. We send down the style sheet one time at the beginning of the connection, like, hey, here's the whole style for the game. Client, use this to style everything. which I think is fine for now. If we, maybe a future expansion, we might change that. But or if you wanted to update this game and have like more dynamic graphics, you would change the style.py and make that more dynamic. But right now, AIs just have a static render code, and they have some name, some race, some health, base power, and base defense. So this item maker's monster factory will create them. There's also an item maker. There's other factories like for weapons, tools, explosives, armor, etc. That just makes different kinds of things like armor create boots. Okay, so going back to the avatar, to the AI, so create an AI, let's look at like orc.py. So this is the orc AI, inherits from AI controls, and this is going to be on a regular avatar object that gets this AI component added onto it. So on its turn, instead of getting its input from the player, setting up controls from the client, it's going to be taking through and saying, ooh, what should I do? What should I do? I have some base AI. And you can see the orc, he's friends with things that are imps, but he's an orc and has some render code and some pretty low damage, base power, base defense, and some health. So this guy's really, really simple, really straightforward. Look at the AI, AI.py, you can see a bunch of default behavior that could be overridden. These things like wears armor, they're aggressive, they're greedy, they crave corpses, who are they friends with, what kind of items they ignore, do they use inventory, can they swim? Don't think this is used yet, but will be. If they adjust their target, and then a movement profile and pathfinding with just some defaults there. We set up the AI with some basic information. What does it see? Visible objects. What are its avatar targets that it wants to attack, and what are the item targets that it's interested in. Field of view. The render will be updating that. Its current pathfinding, new path. The last direction, it's a vector x and y. And we'll get the name assigned. So you shouldn't really have to change anything in here, but you'll be overriding stuff here for new monsters, like we saw in Orc. Override some basic stuff. And on its turn, it'll get called with get intent. And I believe, let's just do a search for get intent. Does game call that, or is it AI input? Yeah, AI input. If there's an AI, avatar intent, AI get intent. Passing an X and Y in the avatar world map. Okay, so default is just to do get standard intent. And this is our base AI implementation. So you just want an AI that kind of does the default behavior. You just use the standard intent. This also means you can override get intent and have it do some special behavior sometimes. And then if you want to default, you can just call get standard intent and it will do that. And intents always follow this pattern of having a type, an item, and a direction. I think I made item optional now, but you definitely need a type and a direction. So yeah, default direction 0, 0. It'll try to update its path to a nearest target. And if it doesn't have a path, it'll just do some default exploration, which is kind of pick some random places to go. And yeah, so this will just make it pathfind towards enemies and items that it sees. And just go around and pick stuff up. Now, let's see here. Yeah, now this update path to nearest target will use its targets, and by default we use the all targets, which is going to be from avatar targets and item targets. And I believe this gets sets from knowledge. Filter targets. Okay, here we go. Yeah, so we get an update knowledge message, and if the type is visible objects, then it will save the visible object it knows about and then call filter targets. And filter targets will say, okay, I don't have any targets, and then it goes through the visible objects, and if it's a valid avatar target, it will append it to its avatar. If it's a valid item target, append it to item. Valid avatar, if this creature is not aggressive, then it doesn't care about other avatars. If it is aggressive, then it checks it's a valid race target and a valid aggression target. So by default, entities will attack things of other races unless they have a friendly race like the orcs and the imps. And then just valid aggression target lets you do some override logic if you want to, like maybe conditionally attacks enemies. Okay, the valid item targets, if it's greedy, it wants to go for items, but if the item can be picked up and this guy's inventory is not full, then it will try to pick it up. And if it wants corpses and the target type is a corpse, then it will be a valid item target. Otherwise, it doesn't care about that item. So you can override this stuff and do these filterings to determine if maybe you ignore certain types of items, or you have a creature like a snake that only eats wands or something. You could do that here. So looking at let's look at the Minotaur. It's a little bit more complicated AI, I think, but still pretty simple. So we have some default overrides. It's got some health, name, render code, base power, base defense, that kind of thing. But its intent is special. It does need inventory, so it doesn't care about. It's not going to pick items up if it runs over them. And its configure, use the default configure, always call super there, and it'll have a lock direction of none by default. So it's just sort of hanging out, and the lock direction is none, and then it's going to update path to its nearest just avatar targets. So it doesn't care about items, but if it sees an avatar, it will try to vector towards them, and when it does, the target is valid, then it'll save a lock direction. So the else statement here, if it already has the lock direction, it will just continue in that lock direction. So this is basically like a bull charging, right? The Minotaur sees you, he's gonna start charging towards you, but he's not gonna turn. He's running in a blind rage at you, and when he gets the collide message, then you hit a wall. Then he's gonna go ahead and disable his. Well, if he hits a wall, he'll actually destroy it by sending messages to world map. But whatever he hits, his lock direction will be set to none. So he'll charge until he slams into something, and then he'll look around again and check for something else. You can see it's a fairly short AI class still for all that behavior. It's just like sort of metadata about him, and then just a few functions for overriding his intent and updating the intent. Okay. So that's an overview of the AI. So reference the item spawning in the map a few times. So let's look at a level. So all the levels are in levels.py, and I'm pointing from here. This is in librlengine levels / file name. So we'll look at town. It's a great map. Inherits from the level base class. It's got a level name, tainted town. This does the styling on it. So let's see, we've got some comments for what those different codes mean. So we've got some dirt, some grass, and that's our symbol for it. That's actually the ASCII symbol, and then color, background color. Checkering. So if checker is none, it'll just be a solid tile. If we checker, it will tessellate with another code. Like in this case, 127 grass will tessellate with 8280. Got a house wall, special wall, the water, and a fence on the grass. And you can see there's some, fence doesn't block sight. So if you put block sight false, then you can see through it. Then we've got some items, and so the way our mapping works is it's just strings, basically strings of characters. So kind of make your own little short code, and then say like, okay, in this case W, I want that to be 3 indoors code. So the 3 refers to that 3, and it's going to be a stone wand. So some of these special rooms, like here, could have these stone wands laid out. So generating the map. Oh, and similar to items, there's also monsters. Yeah. Yeah, so our level.py gets called with make map and gets told about the game and the world map. So we call map maker, which this basically does a bunch of procedural generation for generating rooms using libtcod. Thanks again, libtcod team. And then we'll reset the extra information. This is because our level objects stay in rotation, stay instantiated. So as you go through a rotation, you just need to reset extra items, extra monsters to spawn. Then we'll add special rooms and then finish it off by building a perimeter around the thing just to wrap it with a border that can't be destroyed. So add special rooms by default does nothing. You can also say we have a default style here that we override in town. So this is like the basic dungeon, I think just cavern. Well, I think we actually override this in cavern now, but this is like the basic style. Yeah. Yeah, so like Boulder Bash doesn't override the style. Town, though, does override the style. And add special rooms get called. So at this point, we've already got a procedurally generated rooms with some map width and map height and recursion depth for the procedural generation and a minimum size 6x6 for those rooms. And no wall peppering. We don't need to tessellate the walls with a checker pattern. And full room is false. Riley, for full room is false, that means they can kind of run into each other. Is that right? So if full rooms is true, that makes, what does that do? All the walls are thin. Okay, so full room is true means all the walls are thin. Okay, so that'll like keep trying to place rooms over the map so the walls are thin. Oh, okay. Yep, so I misspoke there on wall peppering. That's not tessellation, that's actually placing pepper on the map. So like stalagmites on the cavern level. So by default that's 0, but if we look at cavern, we see we've got a wall peppering 8, so it'll randomly place the 8 symbol here on the map. Okay, my mistake, up to 8 stalagmites. So that'll place, now do we specify, does it know to pepper with 6 by default? Okay, so these numbers are kind of magic numbers here where 1 through 4 is floors and then 6 will be the special peppering. And then you've got a couple other codes here if you want to use them for your own stuff. So back in town, we're going to do add. Say again, Riley? Okay. So add special rooms. So this is special rooms for the town. So we'll look at the top strip and decide what that should be. It might be nothing, or it's going to be this map, one of these maps here. So like that's one possible top strip. That's another one. 7 is water. 2 is grass, back on our style map. And M's monster for orcs. There might be some orcs chilling by the water here or over here. And yeah, then we'll call place room. Yeah. Yeah. So we'll place a top strip, and then we might vertically flip that with the V flip, and we'll place the middle dirt in the middle, which is just a bunch of dirt, and okay. Okay, I misspoke about the vertical flipping. That could be placing one of the top strips at either the top or the bottom. So this could be at the top. Either one of these could be at the top or at the bottom. Then we'll place the dirt, And now we'll go through and place the town pieces, and we permute through all the possible permute square rooms. Oh, is that a base? Yeah, permute. So here we look at all the different permutations of default vertical flipping, horizontal flipping, or vertical and horizontal flipping. So all different ways you can rotate a room around. And then we'll place the room for the game and world map. We get the placing variable there and a 3x3 grid, and then these are our offsets based on the height, width and height. Is that right, Riley? Cool. Yeah, so this will go through, and then you can see we've got our town pieces here, custom town pieces drawn in here. Do note that we try to keep some spaces around so that you can't get blocked in. The little pound sign will refer to a fence, space for space. Then you can use 1 through 8 for the regular styling, and then the custom characters for monsters or items. And then item maker maps. So if you remember earlier on in the video, I talked about the levels loading with an item config. And this will come from the level item maker map information. Oh, there's also win condition. Right now everything's timed, and this might change to King of the Hill or something. Then we just override those functions. So we'll have an item maker maps, which will know about attack items, equipment, starting tools, all these different sections. And these are a minimum number of things, like a minimum of 4 lightning wands, 3 fire potions should be on the map. And what happens is that will get called with item maker delays and the item maker delay reset. So this is the delay from the beginning. So like the tools won't come in for 400 ticks. The starting equipment, starting tools, that gets put in right away. The attack items will come in after 100 ticks. So kind of nothing happens for a little bit on attack items, then they'll show up. And then every 200 turns, we will just refresh the attack items. That kind of just keeps the items refreshed. Keeps enough equipment going on to be interesting. But then stuff like starting tools, 10,000 is past the timeout, so we don't need to show the starting tools again or starting equipment. And then weapons, put in some weapons after 400 turns, and some armor will come after a little bit, and then timeout. So yeah, this is how you can customize the timing of the items post their initial appearance and then their reset. And minimum monsters. Oh, I think we fixed this on a branch, but I'll fix this. Haven't marked that in yet. So minimum monsters, this will be how many monsters show up on the map, and this will be in this case orc, ninjas, and spiders. So the monsters will get spawned with weights. So orcs are most likely to appear with a weight of 30, ninja weight of 9, spiders weight of 7. So in this case, the ninjas and spiders are usually able to kill the orcs, so they're less plentiful. That way, it sort of kind of has a kind of even balance of everything. That can change a little bit, but that's part of the excitement of the game too. Is you might find a town that's been taken over by ninjas or taken over by spiders or all orcs or something, just based on how the fights play out. Okay, so that's an overview of the level system. Yeah, so we showed you the town. You also saw that if you left the play special rooms function empty, you would just get a procedurally generated room like in bash.py. Now to show you a more custom level. This is our temple level. And Riley made this outer edge and then some lines to show like, hey, the stuff in here will be drawn by something else. And different variations. So we have 2 possibilities for this outer layer. A second layer can be one of these or one of these, and then an inner layer. So what happens in Play Special Rooms is we'll pick the outer edge, and that 5, 5, right, that refers to 5 coordinates down, right? Like 5x over and 5y over. Right, so we have the the random generation runs first, and then we're going to place the outer edge 5 over in the x and y direction, meaning that the end result is that the outer edge of the temporal map is still procedurally generated. So you can think of it as like we draw our map, and then we're just like cutting out the middle, or most of the middle, and putting in our outer edge. And then we're going to cut out the middle of that, 5 more tiles over on 1010 and put in our second layer. And then we'll figure out what we want to do for the inner choice, which will be chosen and then rotated around, or possibly flipped horizontally or vertically. And then we'll place the inner layer 20 tiles over and 10 over. So you can really customize the layout of your level and still do procedural generation with that. And here's the items in the monster by default. We showed you that already. And then see the outer edge. This is one possible outer edge map. So you can imagine these just kind of being put into each other layer by layer, and the edge is still procedurally generated. And then Temple has its own set of items. Yeah, so showing another level, this is the Lewd Labyrinth, and this has custom style. It also has an occlusion factor of 0 as a parameter here. So if you change this occlusion factor value, you'll actually darken what's outside of the field of view. So if it's 0, anything outside of the field of view, instead of being darkened partially, if it's 0, you just won't see it at all. So this is nice for a labyrinth because I want you to feel like you're really down in a labyrinth, don't know where you are. It gives a really nice feeling of kind of being lost. Whereas like in town, with an occlusion factor that's higher than this, you can still kind of, the general layout of the level. So generally I think having a positive occlusion factor is good, but if you want to make a level like Labyrinth where you just can't see anything, you're totally lost, then 0 is a good choice. And Labyrinth doesn't have any sort of special mapping. It just has, it's pretty big, 40 by 40. And it has a higher depth, recursion depth, and a small min size, room size, 2 by 2. So the result is it's a little more twisty, a little more zigzaggy inside. It also has a higher monster count to account for its big space. And then you can see it's got its own set of monster weights there. Yeah, so that's an example of a few different levels. So you can use this information to make your own levels and do custom drawing, or use the procedural generation, mix and match, place items and monsters on the map. Yeah, whatever you want to do for a level. Whew. Anything else we want to talk about, Riley? Yeah, it's hopefully this gives you a good first impression. I think if you are just kind of spend time looking through the code base and understand, I'd say it works pretty well. It's probably maybe 70-80% good code, and maybe 10, 20, 30% duct tape. Some things are duct tape, some things like maybe we can think about that a little more. But I think the base of it is pretty solid. It works pretty well overall. There is some things happening in a few different places like the events, but hopefully this gives you a good tour of what those things are and how you can manage them. And yeah, any questions, just ping us on GitHub, or join the Discord and just drop a message there, and we'll get back to you as soon as we can. And yeah, thanks for watching. Thanks for playing WizardWars.io, and look forward to seeing you online.